Okay, in this presentation we're going to look at a probability problem. Okay, so we have two events, A and B. The probability of event A is 0.72, the probability of event B is 0.60, and the probability of A and B, this is the intersection symbol there, it's probably a little bit faint, but I don't want to make it, yeah. So its probability of A and B is 0.48. Okay. So what we have to do is calculate the following. So we have the probability of A union B, or which is A or B. Okay, that's the union symbol. That's the complement of A union the complement of B, A given B, the conditional probability of A given B. Okay, and then of course our A and B independent events. We'll sort of have a look at that shortly. Okay, so what I'm going to do actually is use a Venn diagram approach. Okay, so we're told a couple of things here. So actually I'm going to just sort of go back up to the top. And I'm going to use all of these pieces of information here. Okay. So this is the important one to start off with. But because this describes one region alone in the Venn diagram. Okay. Which is right in the middle. A intersection B. 0.48. Okay. Now we're also told the probability of A is 0.72 and the probability of B is 0.6. But we've already accounted for, sorry, I'm just scrolling up and down there, okay. So, but we're already accounting for some of that. So we already have 0.48, so there's just another 0.24 to unaccounted for A, and likewise 0.12 for B, okay. So if you look at what's in the circle here, for the circle that describes A, that one there, the left-hand side circle, that is 0.72 altogether. So it's essentially the 0.72 is the sum of A and B and A but not B. Okay. Likewise, 0.6 is A and B but not A. Okay, which is 0.6, 0.4 plus 0.2. Now, so the probability of A union B, let's just write it underneath, is the sum of all of those. 0.24 plus 0.48 plus 0.12, and that is 0.84. That means that the remainder actually, just actually as a remark, is 0.16, not A and not B. Okay? So, that is the answer to our first question, essentially. Okay? So I'm going to move on to the next one here. The union of the complement of A and the complement of B. Okay. Now, so what I'm going to do actually is I'm going to sort of put a little red asterisk for the regions here that describe the complement of A. So, for example, this region here, that's both of them. Okay. Now, and then I'm going to an asterisk that describes the complement of B, and again it's this region here and this region here. Okay, so it's essentially we've actually almost all of it accounted for. So just actually so we have 0.16 here, 0.12 here, 0.48 and 0.24. Okay. So what we're going to have to do here is pick out which regions, actually I'll just for like the sake of clarity, I'll just actually make it a little bit clearer that the complement of A is the regions that have color coded a bit, okay? So I'll just let that focus actually. Pause it a second. There we go. So essentially what we want to do is just actually add up all of the regions that have stars, the probability of all of the regions that have stars. So the probability of A complement union B complement is 0.16 plus 0.24 plus 0.12. Okay, totten that up, that should work out to be 0.52. So that is the answer we are looking for. Okay. Now, the next question is the probability of A given B, okay? So this is our third question. Now this is quite simply using the conditional probability formula. So A union B all over the probability of B. Okay? Now that's a formula that you just really should get to know very quickly. Now A union B, just above, is 0.48 over 0.60. Okay? That's just like the information we were told at the start. 0.48 divided by 0.60 is 0.80. Okay. So, yeah, that's the answer to that one. So that's just a matter of learning off this very important formula. Okay. Now, finally, are A and B independent? So, what we have to do here is multiply probability of A times the probability of B. Okay. So that is 0.72 by 0.60. Okay. Working that out, that is 0.432. Okay. And is that equal to the probability of A and B, no, which is 0.48. They're not equal. So probability of A, they're not independent events, is not equal to probability of A times probability of B. So that means that they are not independent events. Okay, sorry, that's just a little bit unclear there. Probability of A. Okay. So that ends our presentation. We've got all the main points done.